All right, is this working? Probably don't want that streamed. Okay. Currently, I'm not seeing any viewers. That's fine. I'm not too worried about viewers or not right now. I honestly just want to see if I can get this to work. We'll pop that out. Chat will go there. Probably shouldn't have that there. Okay. We'll pop this out. We'll move this here. Views, 0. That's okay. I'm not sweating it. That's stupid. I can't even see how many I can find. Okay. I will figure out how this software works sometime later. For now, because this will probably be on my channel at some later point, this is my first ever attempt at live streaming, and finally I can live stream. I think someone at YouTube might have been listening to my complaints, and if that was you, I appreciate it. But yeah, today we're gonna be doing some live coding. This is a huge risk because this project I've been working on is I've been posting like stuff on my X account on like what it looks like, but no one's seen the source code yet, and I'm opening myself up to some flame with this. So yeah, let's see, let's check this out. So today, honestly, this is more of a demo to see how the whole live streaming thing works, but this is the project so far. Okay, so as of right now, it's just a chill demo scene, and I've got some cool debug features. Let me make sure I can actually see my stream. Warning, the current, is that an issue? Okay, if any of y'all are watching this right now, let me know in the chat if there is any audio or video problems. If you can hear me all right, if you can hear the music in the background all right. Yeah, this is my first attempt at this. I'm totally new to live streaming. So if there's something wrong, I'm not gonna know. Oh, I appreciate that. You're the first ever comment on any of my streams. Balthar7968. I appreciate that. Everything normal? That's perfect. That's good to hear. Okay, so let's get into this. Your mic is kind of low though. Okay, so if any of y'all watched that video that went a little bit more viral, my mic was terrible, and the #1 comment was how bad my mic was. I have a new mic. I have a new mic, okay? I listened, I promise. It was expensive, so hopefully it's better. Let me just adjust a little bit, okay? All right, let's get into this. Okay, so right now, whatever. All right, right now, it's pretty much just a chill little grass scene, and what I'm going for is sort of like a Tiny Glade aesthetic. If any of y'all know what Tiny Glade is, it's this awesome game where you just build these really cool structures, and the rendering technology in that game is particularly interesting. It's they have a GDC talk on it, on how they did all of it, and it's written in Rust and Vulkan, 2 things that I am going to learn next. So yeah, I'm trying to just kind of try my hand at rebuilding something like that in OpenGL. But as of right now, feature-wise, you know, I'm doing some shadow map calculations, just very generic shadow maps. As you can see, the only thing that actually, you know, casts shadows are the trees and rocks, the grass, the terrain, none of that does. And I mean, you can turn off the grass. I do have a terrain level of detail. So if I turn off everything except the instance meshes are a little busted. If I draw wireframe, you can see the level of detail of the terrain changes based on how far the camera is from it. And believe it or not, this was actually relatively easy to implement. OpenGL, learnOpenGL.com had a great tutorial on this, and it pretty much suited like my exact use case, which is pretty awesome. So the terrain, pretty straightforward. What I'm really proud of with this project, what really is cool, is the grass. And there's a reason why. This is my first time using compute shaders in OpenGL. And the reason I'm using compute shaders is because rendering grass is hard. Instance rendering is a rabbit hole. It's very easy to do it in simple ways, so using like shader uniforms. But to do it properly, and in the case of grass specifically, you have to, like, let me just show you what I mean. If I turn off the compute shader that's running, you'll see the grass, there's a cutoff point, and you'll notice that that is actually frustum culling being done in the compute shader. So if the grass is not visible by the camera, it doesn't exist. So if I turn this back on, you can see, you know, it looks like there's grass everywhere, but there's not. It's dynamically populating wherever I'm looking. And that's pretty cool. That was pretty hard to implement. And then there's some render like features, you know, like camera far plane, clip distance, all of that stuff. You can reload shaders live too. That's another thing. So if I make a tweak to the shader, which I will, let's see, let's go to the grass. Let's make everything, actually, yeah, grass instance.frag. I just want to make the out color in the, like a terrain space UV. So, terrain space UV, we'll actually just do vec4, terrain space UV, 1.0f, 1.0. All right, not that. And then if I save, do that, and then reload shaders. Why is that not working? Ah, yeah. Okay, reloaded the app. In my defense, it's been a hot minute since I've tested this. Okay, so it is reloading the shaders. Oh, I just did it in the wrong shader. I'm so stupid. Wow, that's a little embarrassing. Okay, save it, reload shaders. Ah, there we go. See? Everything's updated. You can kind of see the grass's terrain space positions. And if I want to change it back, I can just delete, save, there, and it all works. So it makes shader development pretty fast, actually. And I don't want to change anything with the post path. I don't know why. This shader actually is not being used right now. I probably should delete this. But yeah, it's a pretty straightforward, cool app. But what I'm thinking I want to add is I think I need to add some stuff in the scene. Right now, tech-wise, most of the stuff is just done. Grass is done, trees are done, rocks are done. Someone suggested that I put ambient occlusion into this. That would be cool. I'm not sure if it'll be as like visible. Really, the scene doesn't have a lot of like nooks and crannies, and that's where ambient occlusion really helps. So I think like I want to just put some sort of like wood items in the middle of the scene. So what I'm thinking is I will just, actually you guys will kind of get to see what it looks like to add something to this game, or scene. It's not even a game. Let's add like some wood planks. So we'll do that. Yeah, we'll just add a wood plank, make some stuff look kind of fancy. Bevel there, and then we'll make this whole side beveled. All right, that's a good little wood plank. We'll just duplicate it. Oh my gosh, Control A. Why is, man, is my stream breaking something about like how my keys are working? Because Shift A is not selecting everything. Okay, whatever. That'll just be our little demo thing for now. All right. We'll export that as wood planks. All right. We don't say that. All right. Now this should be in our scene. The CMake system I have set up is fairly generic, but I will walk you guys through it. Okay. So the way the CMake is set up for this project is essentially, Yeah, it's a pretty standard CMake file. As you can see here, you know, I did have to manually copy a couple IMGUI source files into my project. I probably should go back and do this properly, like properly link IMGUI as an external library, but right now it is like directly copying sources into my binary. Probably not the best way to do it, but these are all just external libraries I'm using. This is actually my library that I wrote for input. I am using it. And then yeah, fairly straightforward. Okay, so this was written in a JetBrains IDE initially, and JetBrains, they're awesome. I love JetBrains IDEs a lot, but they will manually add stuff. They'll automatically add stuff to your CMake file. So for example, all of these files, I never put them in my CMake file. They were automatically added. Technically, they should just be encompassed in this source file, in this source variable, so I don't need them. And then, you know, we're linking to our external libraries. This is the command that is really crucial. I copy everything in this resources folder, which has all the meshes, shaders, textures, into the binary folder. So if I then go and like go to the project binary, you can see the resources folder is in here as well. And that's how the binary can access all my resources, using like local path from the executable in my code, which makes things really easy. But it does mean that anytime I import something, I have to reconfigure the CMake project. But yeah, it's pretty easy. And then if I actually want to add this plank, we'll just add it here. Plank project. All right. I am using entity, ENTT, for my entity component system. And so far, no complaints. Actually, minor complaints. I'm used to using like Unity's entity component system where you can have multiple of the same component on an entity. You can't do that in ENTT. So one component, if you add it to an entity, that's it. You can't have like multiple colliders on the same entity. You have one collision component, and that makes things a little trickier than just using like Unity or something. We'll put a transform on this, and then let's see, yeah, plank. We don't need to initialize that. And we won't do instance rendering. We'll just mesh component mesh equals registry dot place mesh component blank. It's weird live streaming. Usually I don't have to think about the fact that people are watching you write this code. I feel like it almost makes me slower. I'm sure I'll get used to it. I am going to try to make this a little more regular. Okay, mesh component. I probably should not have named this mesh because it's not a mesh. It's a mesh component. That's a different class. A mesh, I'll show you the mesh component class. Mesh component class is literally just a wrapper for a mesh. I did this purely because if I ever want logic that kind of sits above a mesh, which a mesh is like for graphics purposes, and then a mesh component is like that mesh in the scene. If there's something that lives in between that space, some logic of some kind, it'll just go in the mesh component. But if I want to load a new mesh, I have a static method in the renderer that just lets me load a mesh asset, and then I just pass it the local path, which I believe this was what meshes, wood planks. Yeah, wood planks.obj. And then we specify a material asset as well, but this is a pretty much useless feature, I'll be honest. Like, I don't read the material file. In fact, now that I'm thinking about it, I probably should get rid of it completely. And then we specify whether it's an instance mesh, which is false by default. Isn't it? Oh, I guess not. I guess I have to manually do it. Okay. Next, I think I'm gonna rework that. We do not. Yeah, we want to keep everything the same. We should make its color something nice. We'll make it red for now. All right, and then that should be it. Yeah. Although feel like because, what's this even do? Oh yeah, there is technically a parenting system, okay. We will parent this to the terrain. And then, that should be, sorry, I have a little bit of the flu right now, to be quite frank. So, yeah, if I ever clear my throat like that, just know I'm struggling. That's weird. Why is this bugging out? I'm sure it'll fix itself when I compile. All right. Oh, it's not fixing itself. That's not fun. In place. Registry dot in place. Transform component blank. Oh, I put this in the wrong place. Yeah, there. Now that should fix everything. All right, and this should spawn in the center of the scene below the map, possibly. We might not be able to see this. And the other thing is I haven't actually rendered like just a standard mesh in a while. Everything on screen right now is using the instance mesh component, which has its own like shader and its own logic. So I've been doing a lot of work on that and not on standard meshes. So there's a chance that this may, for some reason, not do what I was expecting it to. All right, let's run it. I called it. There's something wrong with the vertex shader. All right. Opaque instance, opaque lit. Maybe I have to do that. That's okay. I should get rid of the post pass shader because I deleted that, because we're not actually like, there's no post pass actually happening, and I need to get rid of all of that. I shouldn't just have unused stuff like that. Post pass. Yeah, we'll get rid of that, and then get rid of that, and we'll get rid of that. All right, that should be it. And then what is going on here? Must write to GL position. Okay. Am I not? That's weird. That shows you how long I've touched this, like how long it's been since I've touched this file. I am writing to GL position. What? Maybe it's because the post pass shader is messing things up. Another thing is when I copy files over here, it never deletes any of the previous files. So if I delete a file in resources, it doesn't get deleted in the binary. That may be the issue. If I, no, that's not the issue. Okay, let's recompile in the meantime. All right, what's up, Marco Martin? What's up, bro? We got 4 concurrent viewers. This is pretty cool. It's a lot easier than making YouTube videos. I'll tell you what. The YouTube videos with college, man, it's hard. It is hard to edit. Ah, it worked. You can see the planks. They are in the scene. Let's just move them like up a bit. All right. This is fun. I did not think I'd have this much fun. All right. Dot transform dot position dot y equals. We put it really high up in the air because honestly, I've been meaning to add a wood material, and now that I think about it, I think this might be the perfect time to add a proper wood material. Oh no. Permission. Oh, it's still running. I'm so stupid. Yeah. Okay. Which means I have to make a new shader. The one thing that's not great about this engine is, you know, I can't write a shader that's just like a wood shader that I apply to instance meshes and non-instance meshes. I have to rewrite the shader twice, essentially. Once for the instanced meshes and once for the regular meshes. And that takes a little bit of time. But yeah. Yeah, you can see shadows are working on it. They do not look very good with the current shadow color. Like it doesn't work well with red. but they do work, and it's casting shadows. You can see that's nice. That's working. All right. What are we thinking we add? We've added wooded planks. What time is it where you live? It's like Central Time. It's like 5:30. I was thinking I'm just gonna stream till like 6:30. So, a little bit of time. I mean, kind of a chill afternoon. 8 views. That's cool. All right, let's see. I think maybe the play would be to add some sort of like, this is the reason I don't do game dev and why I do more engine dev and like graphics programming, because I'm not a terrible artist, but I don't enjoy making art. I enjoy writing code. I hate asset creation, which is why every time I've done a project with someone else, it's been, I write the code, they do the art. Although I don't always like being the only guy who writes code. That can be kind of frustrating. Okay, let's actually get a color for this wood. 1.0 to 1.0 RGB color picker. This is like the most niche website ever, but I've needed it because all of my materials work on like a 0.0 to 1.0 RGB scale. Actually, wait a minute, I already have a wood color in here. The tree stumps are a, let's see. This is the stump. No, this is the stump. All right, albedo. And then we should throw that here, and then we'll have them use the same shadow color as well. Mesh dot material dot shadow color equals shadow color. All right, and then roughness. Yeah, we should definitely have a full roughness. I actually would like to have like a demo material sphere, like, you know, the spheres. Actually, it's a good idea. Material demo mesh. I'm gonna use one of those cool material demo meshes, like those weird sphere things that like are meant to display a material, and I'm gonna put it in this game, and that's how we're gonna demo some materials. Material demo sphere, maybe that's what it's called. Demo sphere model. Download. Yeah, that's what I'm thinking. Like this, material ball. Yes, material ball obj file. And then we'll check this out. Okay, sketchfab, material ball, blender material ball. You know, let's see the poly count on this thing first. I don't want to do anything too, let's see, wireframe. That's dense. That is dense. We will be pushing the engine a little bit, I'm sure, if we, but that's even more dense. Okay, we'll use this one. This one has much better prospect of working, I think. And then we'll import it into Blender first to make sure that everything works. And then in the meantime, I'll show you what the wood now looks like. See? Already looking a little better. Although interesting, that looks a little brighter than the trees. Because you can see the tree stumps look like that, and this. I wonder why. Maybe because they're all in shadow, or like most of them are in shadow, but I don't know. That's interesting. Oh, I know what it is. I know exactly what it is. All of the trees have cull back faces disabled, so they're casting shadows on themselves. And that is because the leaves they don't work very well if you don't turn off cull back face. If you don't turn off cull back face, the leaves all kind of, well, you can see like through a lot of them, and that's a problem. So sometimes you have to break the rules a little bit to get your renders to work. And then let's see. What? Okay, why is this is a suspicious looking folder, to say the least. Why is there a zip within a zip? Okay, whatever. If if I get a virus, at least it'll happen on stream. And that'll be mildly entertaining, I guess. I don't know. I need to fix this computer anyway at this point. What is this folder even called? Okay, there we go. Ah, perfect. Alright. Put it there. I don't need to save that. I'll save it. Demo material sphere coupling. Now we'll export that to meshes demo material sphere.obj. All right, and now we should just be able to import that demo material sphere. Oh. And then the other thing I need to fix is actually either read from the material file or just not ask for the material file. I literally have not used it at all. I haven't even tried to parse it. So I don't even know why I have that option. Okay. Music's nice. All right. Ah, it runs well. Runs very well, actually. And cull backface is also off, but it doesn't seem to be making any real difference on the... No, it is. That's what this weird artifact is. Let's see. I need to turn cull backface back on. It's on by default. And the next thing I'm going to do is I'm going to... Do we read from the material asset file? Because now that I'm thinking about it, if we could just color things in Blender, that would make things nice. Let's see. What would it even take to parse this thing? I really have done like no research into this. There's no materials in that. We could use like vertex colors. I don't want to use vertex colors. I've done that before. It's tricky to do anything meaningful. They're good for like using, you know, vertex data, but they're not good for like. That's weird. There's still that shadow artifact going on here. I mean, can I see inside this thing? Hold on. No, it's calling back faces. We're good. Okay, so that's our wood material. I think we should definitely upgrade this though. Like this is not nice enough. I also think shadows need to be a little darker. Like that's a really light shadow. Let's see, how am I doing shadows right now? Shader utils, lighting calculations. Okay. Yeah, that's for the actual shadows. That's not even for just like the standard dot product stuff. Diffuse. Let's see, we're mixing cool sky, and cool sky is probably just way too close. See, this makes it where the whole scene looks very homogeneous because you can directly say like what the sky color is, what the cool sky color is, and everything just looks more nice. But the problem is some materials it works really well with and some it doesn't. So like as you can see, the trees look pretty good using like a shadow color like this, but the wood does not play as nicely with it. Okay, maybe just turn up the diffuse strength. We also, yeah, the ambient might be what's messing this up actually. We use that real-time shader reloading feature I was talking about earlier. Just hyping up. Yep, that's already a lot uglier, but it does seem to do something. Reload shaders, all right. Look at the difference here. I mean, that off the bat looks, but that still isn't the issue because you can still see the shadows are really like not intense. I like the ambient. I think maybe we need to get rid of this like 0.5 multiplier and this brightness. We'll literally just use the plain dot product. Let's see if that's a little more aggressive. That is more aggressive. I like that. A little bit more. Let's see, what if we just added that 0.5 add there? Yeah, that's even better. I like that even more. Ooh, that's intense though. Is this really the best we can do? It's definitely not. Muted. That 0.5, I don't like that 0.5 right there. This is going away for good. And then let's see what this looks like in the instance renderer, because, sorry, in the instance meshes. Oh, I'm just using the plain diffuse strength in the instance meshes. Maybe the instance meshes are using a very different lighting thing. I haven't even considered that. Truly, it's been a while since I've considered the differences in these two files. There seems to be no difference. Is there? There is a difference. I don't know what that changed, but that changed something very dramatic in the, that's funny. What did that change? I need to know that. I can't just like, that's what it was. Yep. Okay. I was having this problem with the trees a while back. Yeah, you just multiply the sky color with the custom shadow color of the wood, which we weren't even using at that point. But yeah, this is what the wood material looks like. This is much better. I'm much, much, much happier with this. But I think we also need some like, I feel like we need some like wood patterns on here. Let's see. What did Tiny Glade do for the trees? Trees. I would like to see, because that's what we're trying to imitate here. Oh, oops, my bad, guys. We're trying to get this Tiny Glade wood look. That's not the wood I'm looking for. Tiny Glade. Maybe we can just say wood material. I just need like a close-up on. That might be kind of helpful. Tiny Glade actually just used one material for everything, believe it or not. Everything was so similar. I believe they actually just used one material for everything in the scenes. Well, they had some custom materials, but like different colors, like small parameter changes between like materials. Okay, so yeah, you can kind of see there's that open image in Nintendo. There's that like wood branching. That's what I need. And that'll be a UV thing. In fact, we should see the UVs of this model. I want to make sure this is actually still UV, I think it's PUVs. Yeah, PUV 1.0. Yep. Okay. We do have some UVs loaded in here. That actually looks pretty nice. I'm pretty happy with that. Okay. I think maybe we'll just add some like light noise to this. Maybe pastel wood material. What kind of wood material? OpenGL, we'll just say. Or video game. Unreal, maybe? That's better. Of course, I don't have graphics that look nearly this good. Maybe I'm obsessing over the wood material a bit much, but we'll leave that model there. I kind of like that. I think that looks cool. In fact, maybe this is a good time to demo the different materials that we have in this game. Not plank. Material. Demo. This is still renamed plank. Okay, we'll call this wood sphere. And then, all right, we'll make a few more spheres. We'll call this grass sphere. Do we even have any sort of grass? We'll just call it like metal sphere. Yeah, that's metal sphere. That's what we'll transform M, just to differentiate these things a little bit. Mesh M component. Do not do what I'm doing right now. This is the worst possible way to do it. And then for metal, I mean, what color would work well for metal? That looks good, 0.62. All right, and then for shadow color, we will literally just drag this way down, 0.259. All right, and then we also need that roughness to be like 0.2. Maybe we add like some reflections or something. Oh, we also need to offset this. We need to make it like to the left. Position equals 0.3 off the ground, 0.0. We'll put it like 5 offset. 10.0. All right, let's. All right. We need to. I forgot. We can't build a project when we're running the project. That's not the way to do things. I'm eating this apple so slowly. I think I've been thinking a little bit. I think when I'm done with this project, because what I do, believe it or not, have sort of an end goal in mind. As chill as I've been this stream, I really want this project to be like a resume builder for, that's too offset, for like instanced rendering. Like instanced rendering and like foliage rendering, kind of as a whole, are pretty important just in terms of like any sort of programming with graphics. Like instance rendering is, I believe by default, Vulkan is built using like you're using instanced rendering when you're rendering in Vulkan off the bat, I believe. Although you're technically using something called indirect drawing, which is a whole thing that I had implemented in this and realized it was so overkill that I stripped it all out of the engine. I did not need indirect drawing. But what indirect drawing is the GPU is telling itself to draw things, and it's weird. Yeah, that's not really, that's weird. It looks like it's not reading from the roughness value at all. It's a problem. We're just debugging live on stream. Maybe that's all we're doing. Material.roughness, specular. It's because we're not even using the specular. Oh, and I know why. It is because I deemed the specular not needed for the original thing I was using this opaque material for. Disappointing. All right, render. Okay. That looks a little better. Although it's still kind of bright. And that is because what's changed down here? Yeah, I'm multiplying it by this ambient's getting modified in the other shader. Let's see. Yeah, that's a little better. But we need this specular logic to be used. Like I can't believe I just got rid of it. Let me think about this. Oh, that broke everything. Why? Specular is a vec3. Diffuse is vec3 as well. So what am I doing wrong here? Yeah. I misspelled specular. Final specular. No, I didn't spell it. That's embarrassing. You can see that there is specular implemented though. That's just not the way to do it. I think you add them. I can't believe I'm having to reconsider how to implement specular. Yeah, there we go. You can kind of see the specular results, but we should be mixing. We should be mixing based on roughness. Like this doesn't. Specular times warm sun, and then we should determine how much of that specular we'll actually be using. Yeah, we'll be mixing between these two based on the roughness value. Diffuse specular material dot roughness. I believe, yeah, that might be. Yeah. Although that kind of breaks everything in terms of the wood. Which, oh, we're mixing the wrong thing. We're mixing things the wrong way. Okay. It's a little better. Still some weird sort of artifacts going on here. Okay. Final specular, warm sun, I know this isn't ideal, but I still think it works. Although maybe, oh my gosh. Let's see how low OpenGL did it, just to make sure I'm not completely butchering something that's like, let's see, advanced, this isn't even advanced OpenGL. This is so embarrassing. Yeah, it was like basic lighting. Yeah, basic lighting. Just rubbing it in. No, that looks about right for what our specular looks like. In fact, I dare say ours looks better. But yeah, I mean, it's, yeah. Are they just multiplying with the result? Specular strength. See, this is what my material value was. I use a roughness value instead, and the result is ambient plus diffuse plus specular. Oh. I'm sorry, OpenGL, for breaking your rules. Let's see if this looks better than what I had. I don't know. Maybe. What did I get rid of? Spec times spec. All right. Yep. All right. I'll admit it. OpenGL. I think that looks a little. No, but I still don't want that roughness value to be like. You can clearly see that this is not metal because it's got full roughness, and this roughness is the problem. Diffuse, specular. Like, it needs to be stronger. Oh. I'm gonna cry if that's it. Yeah, okay. There we go. That looks actually like much more like metal. And then there's our specular value. And then now, see, this is the part that sucks about my current development. I have to just copy all that logic into the instanced shader, and then I have to make sure I didn't break everything. Oh, it works. Something changed, but I think it looks, wow, that actually looks pretty good. Okay, so that's a decent lighting demo. Okay. Yeah, we got metal, we got wood. What other material could we even add to this using this system? System, I say. It's literally just like basic OpenGL. You know what? How about I walk you guys through the compute shader? That's much more educational than me failing at doing basic OpenGL lighting. Because I promise you, I'm better than this. What I've spent 90% of the development of this project on is this. So, I believe it was in the draw active scene method. This is rendering scene. Yeah, it's in the foliage system. Systems, foliage system. Yeah, okay. So here's what I've spent most of my time working on, is this compute shader. This is how the grass works in the scene, okay? So the way the grass is, basically, here's how the runtime works for this game. And I'll keep the side view so you guys can see it. Basically, before every frame is rendered, I dispatch this compute shader. And this compute shader is set up to where it runs. It is dispatched for not every blade of grass in the scene. Like, when you dispatch a compute shader, you have to say the dimensions which you'll be running it in. So when you use like a vertex shader or a fragment shader in OpenGL, automatically it's run for every pixel on the screen. When you use a vertex shader, it's run for every pixel on the screen, but also just for every vertex. Like that's what it's being dispatched on. You have to manually say that when you use a compute shader, because a compute shader by definition is just generic code being run on the GPU. You have to specify like the rules for it, which I'm not gonna, never mind. But basically, I say dispatch this compute shader for every blade of grass that I'm gonna place. So I actually have a hard-coded value somewhere in here in the foliage component, yeah. Num instances per axis. So this basically, there's like a large square plane in this world, and then I specify how many blades of grass are along the sides. And if you were to square this number, that's how many grass blades are in this scene. And basically, what I do, I dispatch the compute shader for that. And yeah, that's literally what I do, I square it. And this compute shader, what it does, first thing it does, the grass instance rendering, the transforms for the grass are stored in a shader storage buffer object. So in this grass SSBO. And basically, when you do instance rendering, you have a couple different ways you can get the transform data into the models that you're trying to draw. So the way instance rendering works basically is in OpenGL, normal rendering, you say, I have a model, I want you to draw at this position. And you say that on the CPU. And then you want to draw another model. You say it again, only this time I want to draw this same model at this position. Now, if you want to draw the same model thousands of times, and you have to specifically say, draw it here, draw it here, draw it here, that's slow. That's not the way to do things. So instance rendering is basically, you can have one model, and then instead of saying, draw it here, you give OpenGL a list of transforms, and OpenGL just draws it all in one draw call. Now, you're kind of constrained because you can only draw the same model. You can't draw a bunch of different models at different positions. So the question is, how do you get that? How do you give OpenGL that list of transforms? There's a couple ways you can do it. You can have, you could have a uniform map for transforms. You could just have a list of transforms like this. And then in your C++ code, you would say shader.upload uniform map4, and then your shader name, and then your parameter name. Actually, no, your parameter name would be transforms, and then you'd have to manually put like this. You'd specify and then you'd have the transform that you're actually uploading. This is what your C++ code would kind of look like. You'd have to manually insert the index at which you want to put these transforms in here. And it's actually very slow because uniforms have a maximum size. You can't just have a massive uniform on the GPU. And also you have to upload this every single time that you draw. You have to reset the uniforms every time you draw. So that's one way you could do it. It's pretty much the wrong way to do it, but when you're just starting out, it's totally doable if you don't need to draw thousands and thousands and thousands of things. It works. The other two ways you can do it is you can upload the transforms in a VBO, just like the vertex positions or the UVs. It's literally no different. And I actually do that for the instanced, for the trees and the rocks, they're using instance rendering only. As you can see, there's a VBO for transforms, and then you just treat them like a uniform. It's the same. It takes a little more setup on the CPU side though. And then the other way you can do it is you can have a shader storage buffer object that is dedicated to just holding the transforms of these objects. And what that lets you do is what a shader storage buffer object is it's just a giant chunk of persistent memory on the GPU. You can upload data to, someone said something. You can upload data to the GPU, and then it will stay there between draw calls. So I don't have to every frame say, this is the list of positions, this is the list of positions. I just have to say it once at the beginning, and it'll forever be able to read from that shader storage buffer object. So yeah, that's what this is. The shader storage buffer object is created, I believe, in the foliage system. Yeah, in the foliage system, we create this shader storage buffer, which is just like creating any other buffer in OpenGL. And then we bind it using this bind buffer base method, which basically says, this SSBO is at binding 0. So in C++, I specify this is at binding 0, okay? And then that's it. And I've set up this buffer, and I've said that it can hold a maximum. By the way, whenever you specify a buffer, you have to give a max size. So the shader storage buffer object is no different. And basically I say, this buffer can hold at most this many instances. That's how many blades of grass I could possibly render in this scene. And then what I do next in the foliage system, so I then dispatch this compute shader every frame So this update method is run before rendering anything. I dispatch this compute shader, which is literally just the same, like a compute shader is generic code that's run on the GPU. Think of it like I literally just call a function that's run on the GPU that does whatever GPU logic I need it to do. And then that's literally all this is, this compute shader. It's really great. And you know, when you create so the first thing I do is I empty that SSBO from the last frame because I'm constantly uploading new data to it. And if you don't manually clear that SSBO, the transforms of the grass from the previous frame will stay there. So like when I'm culling things, like culling grass, I need to clear it. Because if I don't clear it, anything that I could see at one point will just stay there. So if I can see a patch of grass and then I look to the left, that patch of grass will stay there. So every frame I have to clear it and then repopulate it. So I clear it, and then I literally just GL use program dispatch compute. It's that easy. It's literally one function call. And I specify how many, like the dimensions of the screen that I want to run this compute. That's what basically like the dimensions of this compute shader. And then the compute shader itself, what it does is, I'm gonna have to get so into the weeds in compute shaders. Okay, so when you dispatch compute shader, you tell it how many pixels you're gonna run it for. Only it's not necessarily pixels. It's just based on how GPU architecture works, you have to specify the number, like the dimensions in which you will. I'm so bad at explaining this. Okay. When you dispatch compute shader, this main function will be run, like visualize a grid, like a computer screen. This main function will be run in each cell of that grid. Now in a fragment shader, the shader will automatically run this main function in every pixel of the screen, is the way you can think about it. You have to tell OpenGL what size grid you're using manually. But what I do is I said how many grass blades I'm gonna draw. And luckily for me, grass blades, like they're already placed in a grid. So all I have to do is pretty much just say, like, dispatch this compute shader for how many grass blades there are in this grid. And then in the shader, I can quite literally get the current grass blade position that I'm running this compute shader for using the invocation ID, which is basically the compute shader's way of knowing which pixel it's on when it's running this code. And then I do a little bit of math to convert this like generic 2D array position into a world space coordinate. And then I basically just get this is the position of the grass blade that I'm going to consider populating in the scene. At this point, it's just a position. And then I have a random offset that I apply to it because you don't want a bunch of grass blades to be identical. I'll show you what that looks like if they are all identical. That's the best part, live updates. Wonderful things. Live update, reload shaders. Maybe the compute shader doesn't magically get live updated. Is there any difference? There's a slight shimmer there, you can kind of see. Maybe we'll come back to that. But yeah, there's a slight offset. And then, now when I first had this project, I did have the ability to have like infinite terrain. And the way the grass was placed was a little more difficult. I placed it based on where the camera was. So if your camera was flying around the scene, you'd always have a patch of grass beneath you, and it would look like the grass was like being loaded in front of you and loaded out behind you. But really it was just the same patch of grass that was being dynamically offset every frame to give the illusion that it was moving relative to your camera. And that's why I had to, the thing is if your camera flew off the edge of the terrain, the grass plane would still be beneath you. So this logic is outdated. I don't need it, but I'm keeping it there just because in case I ever want that back. It's a good feature to have. But yeah, if the grass blade is off the terrain, we're not gonna put it in the shader storage buffer object. We're not gonna render that grass. Next thing we do is, the terrain has some displacement, so we displace the position based on that terrain height map. And then here's the fun part. Here we do frustum culling. If the current position we're considering is out of the camera's frustum, we don't add it to the shader storage buffer object. And then I also do have a max distance value, although, no, sorry, this is not a max distance value. I once did have a max distance, like the grass would. You know what, I'll show you what that looks like. If we're greater than 100 meters away, 100 units. Okay. If the grass is ever a certain distance from the camera, it will not be drawn. Maybe I do have to reload this. If it's greater than 100, distance, position, camera position is greater than 100, return. It looks like I really do have to like reload the application. Yeah, there you go, look. See? If the camera's close enough to the grass, it won't be. If it's far enough away, it won't be drawn. Cool, right? It's a pretty versatile system, I gotta say. Compute shaders are just wonderful things. And then, yeah, that's pretty much it. And then at the very end, we just turn this, you know, vec3 position and the scale and the rotation into just a matrix. And then we simply just insert it into this SSBO we've specified up here. And then in the grass vertex shader, we basically say GL draw elements, and then the vertex shader just reads from this SSBO to know to know the transforms of the current grass blade we're on. And that's it. It's pretty cool. One issue I'm having right now is why is this ugly thing happening here? I think it might be, interesting. It might be because these things are, if you look inside, there's like actually a hollow mini like tube in here. I think that's what's causing these weird shadows. It shouldn't be. I really should redo how the shadows work in this, honestly. Oh, interesting. That's the problem too. It's not one solid mesh. There's like a little neck thing here. This is a bunch of different pieces. You know what, we're gonna change that. That's adding a little too much overhead. Let's see, we'll get rid of these two, by the way. Blender, open, demo sphere. By the way, I'm sorry if today's stream is a little bit more boring, because honestly, I'm just trying out live streaming. Like there was no plan. I was half expecting something to go wrong, and I was just gonna have to say, like, I'm not gonna be able to do this stream today. It worked out. For better or for worse, it worked out, which is cool. But you know, going forward, I think I'm gonna actually have to have a plan for what I'm gonna do. Select loops, edge loops, edges. What if I just delete vertices? Yes, that's much better. Well, select that. And then unselect that. We should select loops, edge loops, vertices. Okay, there we go. And then let's see. I think that looks that'll be a little nicer. It should fix some of the lighting bugs we were having earlier. Reconfigure, and then reload the application. There we go. Yeah, that's definitely what's causing the problem with the shaders, though. You're gonna hate me. I actually think I missed that little thing. Yeah, we'll keep it. I don't like how it looks like without it. Yep. Reload application. There we go. Okay. Well, that's that. I mean, what else? What else is there to show about this project? The grass took a lot of time to set up. Like this project fundamentally wasn't experimenting compute shaders, like learning instance rendering compute shaders, and I think it turned out pretty good. I mean, it's running 85 frames a second. On my cruddy HP laptop at school, it runs at like 13 frames a second. And believe it or not, the biggest performance bottleneck is not the compute shader. It is this draw instance meshes thing isn't working. What did I change that broke that? Draw instance meshes. Am I not even considering that at some point when I'm rendering? Find draw instance meshes. Yeah, we're not even considering that, are we? Draw regular. It should be in this draw loop. Draw shadow map objects. If draw regular meshes. If draw instance meshes. Weird, I must not have pushed that change. I did a lot of this code during school. So it would make sense if I forgot to push some of it. Instance meshes. Rebuild. And then this should show you some of the performance bottlenecks. The main performance bottlenecks are nothing to do with the the instance rendering of the grass. The grass is actually really performing. It runs really well on my cruddy laptop on integrated graphics, but the trees don't. The trees have a lot of overdraw because of how I modeled them, and I will show you that too. The trees, if you were to look at them, the trees are quite literally a bunch of quads that are all slapped on top of each other to give the illusion of like leaves. And on top of that, they have the backface culling disabled, which basically means this is just an overdrawing nightmare. And on top of it, I'm sure uploading matrices to a VBO is not very performant because matrices are very big data types. I mean, map 4x4 matrix of floats, that's literally 16 times 4, which I want to say is 64 bytes. A float's 4 bytes, 4 times 16, that's 64. Yeah, 64 bytes. It's a big data type. So for every tree, there's 64 bytes of VRAM being taken up. Not the way to do things. So, I mean, yeah, that's something that could be optimized. The other thing I kind of want is I like this gray background. I think it looks kind of cool. But I think the next thing I need to do is definitely just like have a skybox, which is probably a good idea, actually. Skybox and like image-based lighting. Maybe that's what we'll get to next stream. Maybe next stream, it's image-based lighting. I mean, I can't do it now. It'll take a little longer than the 20 minutes I have left, but I am going to drag this stream out. But what would, for anyone who's watching, now is your chance. What would you like to learn about this project? What would you like to see? And I will try to get this out of the way as much as possible so I can still see your comments. What do you want to see? This project, this source code is all free for questions. One concurrent viewer. You, one concurrent viewer, what would you like to learn about this source code, if anything? Yes, I'm talking to you, if you're questioning that right now. Let's see. 3 concurrent viewers. Oh, wow. That spiked. You 3 concurrent viewers. I was just asking the previous 1 concurrent viewer. What would you like to learn about this source code? Any questions? Free game. The stream's sort of coming to a close, but I'd like to drag this out a little longer, so free game. Any questions y'all have about how this works? This is funny. I think it's funny. I'm glad you think it's funny. I'm enjoying this. I'm entertained. I'm just happy to not have to be editing videos, man. It is not my joy. I mean, recording the videos and talking to a camera, that's more entertaining, but going in and having to actually edit videos, I don't enjoy it nearly as much as I do just talking. Let's see. What could we add? What could we implement? Maybe we add like a new material. I think that might be kind of fun. All right, material. We'll call this, what kind of weird material can we think of? material, metal B, component, metal B sphere. And then, no idea, man. I just randomly joined. No worries. This is this is my first attempt at streaming. Usually, so far it's just been YouTube videos. So, yeah, we'll see how this goes. I mean, I really didn't intend for this to actually work tonight. I thought I was just going to be fighting with OBS Studio for a couple hours, but it was really easy to set up. So now I've just been streaming for like an hour and 15 minutes, and yeah, my goal is to actually live stream development. Because I do a lot of coding where I'm just like, man, I wish I had some way to like show this. But at the end of the day, I just make sort of like an X post, you know? And it works. I get like 30 views on X, 30 post views, which, you know, I'm not complaining. A view's a view. I'm happy. I'm doing this for love of the game, dude. I'm not big enough to have any reason otherwise. I enjoy this. I very much enjoy this. I think we should do like, let's do like a red, green, blue. We'll do a giant red sphere. Actually, we'll just do like a cool little like car mat, like a soft blue material. That would probably be the way to do things. Let's see. Take this, put that there. Oh my gosh, we'll just combine it. And then for the shadow color, we'll do like that. That looks much better. 2.0. I'll just paste that. I'll have to do this backwards. All right, and then that will be our sort of weird new blue material. Okay. What to add here is the question. So far today has just been like literally just showing off the material system and the engine. And I remember what I was gonna do. This load mesh asset. There's no reason for this material asset thing. Right now at least. It's just getting in my way. I'm gonna get rid of that. Load mesh asset. We don't need this material path thing. It is not worth it right now. Yeah, we don't need that. And then what are we doing? Are we literally doing anything with that? Reader.warning, mesh asset path. I don't think we're using it for anything. I think it was literally just there to make my life frustrating. Oh yeah, load mesh asset. We gotta get rid of this everywhere. All right, that should work. I don't see any other. Oh no, no, we used that a little more than we should have. Man, so many things that I think are like good design decisions to add in when I'm first adding these things, and then looking back, I'm like, dude, I was never gonna have materials, like loading materials from files. Like that's not even necessary for this project. Bool instanced, false. Is that string mesh asset path? What? Load mesh sub asset maybe? Renderer load mesh asset, instance mesh component. Ah, that's where it is. Yeah. All right, that should fix our issues right now, I'd say. Huh, 5 views. That's nice. Glad to see more people are watching. For those of you who are new to this, I'm Literally just trying out streaming for the first time. Oh, I also need to take down that post I made the other day about having to make another account. I wasn't able to live stream for like 6 months. I've tried, and every time I opened up the streaming panel, like on YouTube Studio, it always just told me that it was like blocked, and I never had a reason for it. I never got a strike against my account. There was no reason. So I really don't know. I really don't know. Uh-oh, the music. Ah, music came back. We actually need to, uh-oh. That's interesting. The trees are gone. What have I done? What did I do wrong? Is that maybe where it was? Yeah, I bet you that's where it was. Interesting that didn't throw an error. Why did that compile? That should not have compiled. It compiled with a parameter that the function didn't take in, and then just didn't draw at the top of the tree. I have to be missing something. That has got to be the freakiest like C++ compiler thing I've ever seen. That, I don't even know how that would work. And if the trees work now, they work now. Wow, that was crazy. Okay, so that's our cool little blue material. I mean, I like it. Although these shadows are hideous. Like, why is it's casting shadows on itself? That's a problem. I've been trying to think about how I would fix this problem. Shadows being casted on themselves. Like meshes receiving shadows from themselves. Because like the reason this is happening is because of this like concave geometry. It's like this tube is casting a shadow on the back of the mesh. Maybe, how would I fix that? Maybe in like the fragment shader I can check like if in shadow. That might be the way to do it. Okay. Maybe in the fragment shader we check if the like the model is in shadow, and then if it is, like if the dot product is within a, yeah, that's a good idea. Okay, so this diffuse strength determines how in shadow a face is, and if a shadow is in face, if a face is in shadow of itself, we shouldn't receive shadows. And then we will literally just say times, let's see, diffuse strength. This would be nice if it just fixes all of our problems. I'll be really... Okay, for professional streaming, you need a second monitor for the chat. Believe it or not, I had a second monitor a while back. And then I went to college and I realized, you know, this is really hard to transport 2 monitors. And to fit 2 monitors on it. Like, fitting 2 monitors on a college desk is just, you try it. Let me know how it goes. It doesn't go well. I brought 2 monitors for the first year of college. I only ended up using one of them. So there has to be a way I can view this thing without like, without it showing on stream. There has to be a way. Otherwise, I just can't share my whole screen. Maybe there's like an exclude window thing. I don't know. That's tomorrow's short adventure, but that fixed this problem. I mean, look at that. Did no one else just realize like it was that easy? And now if I apply that to the trees, if I apply that to the trees, oh yeah, they no longer cast shadows on themselves. That's awesome. Well, we did do something on stream today. We fixed hideous shadows, and they look much nicer now. Everything looks much nicer now. I'm actually really happy with how this looks. Like from a rendering perspective, this looks good. Like a lot of times you'll see OpenGL projects and it'll just be like kind of ugly. I'm not gonna kid you. And it'll make you wonder like, why is this guy not using Unity? Like this just looks hideous. But this looks good. I'd be happy to use this to make a game. I just don't know what game I'd make. I also would like to learn Rust and move on to bigger things than OpenGL, to be quite honest. I mean, I'm looking to get hired for parallel compute. So not just necessarily graphics programming, but also just like, I'm gonna learn CUDA soon. And some more low-level systems stuff. That is what I would like to do. Ideally in the Air Force if I can. But yeah, that works. That works really well. And you know, it's not perfect, because you can see some of the shadow still gets applied in the areas that aren't completely covered, but like, it works. I'm really happy about that. Now the other thing is that the shadows are different colors. That's not ideal. And that's what we should change. And I should not have turned that off. Yeah. Yeah, that should be changed. So this shadow calculation, material.shadow color plus diffuse plus strength. What if I just treated the shadow like everything else? What if this is all I did? Let's experiment. Yeah, that didn't work. That ain't it. That is not the way we're gonna do things. But maybe it's the other way around. Maybe we incorporate this into how the shadow color is mixed, because I would like sort of a homogeneous color scheme. So that's better. It's clearly working from the same sort of, maybe this is what we do. Yeah, that looks better. And are we getting from the same shadow color? Ooh. That seems to work. Plus ambient. Maybe be plus ambient on the outside. Not perfect. I don't know. What do y'all think looks better? I mean, I like that this is clearly a way that we can do things. Like it definitely, I just want this shadow color to, okay, so this is what we had initially. Initially, this is what we were using. Oh my gosh. Okay, this is what things looked like at first, and I liked it a lot. But the problem was that the shadow color and the casted shadow color were clearly different, and that is what we're trying to fix. So if I simply was to move all this in here, let's look at the difference. Let's get to a point where you can, better. It's better. And if I get rid of the ambient, we are directly mixing between our shadow color and our normal color. And then the other thing is what? Plus ambient. I think the ambient, maybe we just dial it down a little bit. Yeah, that looks pretty good. I like that. And then what else are we doing? We should just be using this. Diffuse, it should just be a flat value. Wait a minute. Strength. Spec is a float. We should be doing this here. And then that should be it. And then we should be able to just remove, yeah. Okay. Spec. This looks more realistic to what I would expect from an ambient. We don't need ambience right now. We just need raw diffuse stuff. Okay, raw diffuse doesn't look terrible. It just looks bad, but it makes sense. And then we would multiply by ambient. Or maybe add ambient. Add ambient, definitely add, not multiply. I don't know about that. Specular times warm sun, final specular. Maybe the mixing thing isn't. Maybe I'm going about this backwards. And we need to remove that. We need this. This is what we should have. We'll build, we'll reload. That broke everything. That's fine. I don't mind. I can fix it. Uh-oh. What? Oh. Oh. We'll rebuild that. Something crashed. What crashed? Run. Back 3 and float. What did I break? I think I was changing the wrong file. It's disappointing. Back 3 and float. So what's going on with the grass? Is this like animated? I doubt it's actual wind physics. It's not actual wind physics, but it's not animated either. It is, you know, I'll show you how the grass works. Once I can get this stupid thing to work. Diffuse, specular. This should be the code I worked with originally. Why is it not working? Syntax error, runtime error, fragment shader, opaque lit dot frag. And then this is implicit narrowing of type from vec3 to float. That's a vec3, ambience a vec3, diffuse is a vec3, shadow is a float. Diffuse strength. Okay, that's our button. Yeah, there we go. Okay, and this should be back to kind of, okay. So here's how the grass works. The grass, it's not animated. It is, well, yeah, it's not animated, it's not wind physics, it is this. Basically, in the grass vertex shader, I sample a noise texture, which is literally just this Perlin noise texture here. And then I add this. The wind is like the overall, like sort of, if you look at the grass, there's like a very homogeneous flowing motion. That's the noise texture just being essentially like moved across the grass plane, and then I'm offsetting the vertices of the grass based on that noise texture. And then if you look really closely, you can see there's some like slight variation between the grass blades. Like they're not all the same. That is this breeze. The breeze is literally just kind of like a random value that I'm applying to the grass. That makes them look a little more unique. Does that kind of answer your question? Is that what you're looking for? Because yeah, wind physics, wouldn't that be cool? That's all I can say. I mean, it's that would be quite the undertaking. But I mean, I'd be up to the challenge. Interesting. So it looks like this mix thing does work better. Yeah. Does it? It looks really bright. But that's too dark. Yeah. Good. Glad I could help with that. I mean, it's this project. I'm very happy with how it's come across, with how it's come along. But I don't know. I'm definitely reaching a point where it's like I don't know what exactly I'm gonna add to it. But I think I know. I think I know what I need to change. I think I need to stop with this like mixing between shadow color. Okay, let me use some logic here. The shadow color, I just lost my AirPod. The shadow color should just be anything that is in shadow. Yeah, and it should be universally the same color. So yeah, I have a really stupid idea. What if I was to do this? Spec diffuse strength plus spec. Let's see if this does what I want it to do. That ain't it. That is not what I wanted it to do. But that looks interesting. It looks like a really intense gamma. Which I can't say it looks good. But I can say it's a cool experiment. So one day I think we're gonna have to actually rework this, because I really don't like that the back of this, like this color and this color are different. That really, really is not the way I want things to look. Diffuse, maybe, ooh, maybe that's it. Cool sky. Eh, that seemed to fix it actually. And then specular, warm sun. I mean, if we're, yeah, actually. Oh, that looks good. I like that. Sky times warm sun. Let's see how the trees look. Oh. That might have been the way to do things. Obviously, I think the sun's a little too warm. Also, what's this weird, like, seam thing? It's something with the specular. The specular calculations are... Maybe it's the power function. Maybe... Definitely fixed it. Ah, interesting. So the power thing, there needs to be a clamp as well, actually. Clamp. This is such a nested function here. That should fix these weird, like, little specks, wouldn't it? Yeah, that seems to have fixed it. Because if we remove that, we will know for sure. If the specs come back... Oh. Did it do nothing? Is this all a giant placebo? I still see the specs. Okay, that's very visible. Max power of 8.0. What if we said it's like 2.0? Maybe that'll... No, the specs don't seem to be affected, but I do like that actually. I think that looks a lot better actually. Yeah, I like that a lot. And we'll 2.0 there. And then I think the other thing is this like warm sun value. Red, green, blue. Okay, why is this more than one? I do not appreciate having a greater than one. Oh. Interesting. 0.82, 0. Let me get more subtle. I like that. I like that. I think that looks good. Let's see how the trees look. I dare say it looked better before. I take it back. I don't like how dramatic that warmth is. But I do... Man, I can't make up my mind, can I? Maybe that's what we're looking for. I think that's it. Y'all may not have been able to see that microscopic difference, but I did, and I appreciated it. Ooh. Okay. That looks good. 1.1. Let's check the chat. Yeah. That looks better. I'm pretty happy with that. All right. 6:38. p.m. I think it may be time to consider this stream complete, just because I sadly have class tomorrow and I can't be too sleep deprived while sick when I go to class. So we'll commit this, commit all these changes. Let's see. First live stream. Don't really have any real thoughts to go with that commit. Git push failed. Why? Do we have to pull? Is that it? Yeah. Let's make sure this didn't totally break everything, actually. Wouldn't that be a horrible way to end things? Like, redo that, and then we'll do a build. Everything seemed to work. Everything seemed to work. Yeah, everything seems to be working. Yeah, and this looks good. I'm happy with this. Same frame rate, maybe even a little higher. Yeah, good stuff. Good stuff. Very happy with how this went. All right, so that is all for today. I'd say this was pretty fun. This was successful. I hope to just be able to live stream when I develop things pretty regularly. Because these next 2 weeks are going to be a little hectic, so we'll see how often I end up doing this. But yeah, this is cool. I appreciate all you who came in and watched this. This was yeah. This was cool. This was fun. I hope to do it more, and I will see you all around.